All right, here we go. Let's start with number one. You guys can see up on the screen right now. You could have done this in two steps by using the chord theorem. Two chords intersect, the product of their segments are equal. Okay, and that's fine. I'm going to accept that. That's not a big deal. Okay, it's 100% correct to do that in two steps. What I want to go over now, though, is, all right, let's just pretend one of these four segments in the proof statement, one of these four here, are not a chord, and you can't use that theorem. How do I show when I multiply two segments, it's equal to another two segments multiplied together, if I can't use that circle theorem? Do we know what type of proof this is going to end up being? What type of triangle proof this is going to end up being if those aren't all chords? This is a similar triangle proof, and I want to go over all the steps that would be necessary here, because you never know what's on that quiz tomorrow and Wednesday as far as the proof goes. So let's assume I can't use this circle theorem because one of them's not a chord. So let me start here. Number two, yes, this is going to be proving the triangle similar. Only method we have in a proof to prove triangle similar, we talked about it, this unit is angle-angle. So what I'm going to start asking you guys right now, find me one pair of congruent angles in your diagram, please. Whether you did this way or you did it using the circle theorem, I don't care. We should have the ability right now to show me one pair of congruent angles. So let's do it. 12, let's do this. Yep, here we go. Lucas, give me one pair of congruent angles in my diagram.
I joined a minute late. I'm still working on the rope.
Okay, then. I don't have the time here today. 14, Ellie. You got a pair?
Angle DEA is congruent to angle CEB because vertical angles are congruent.
Okay, there's one pair right there. The vertical angles, angle DEA and angle CEB. All right, so right there's a pair of angles. Done. Need another pair. And unfortunately, this is going to have to come from being a circle fact. Give me another pair of angles in that diagram that should be congruent. Here we go, 9. Audrey, got another pair of angles?
Angle ADC and angle ABC are congruent because they are inscribed angles that go to the same arc.
Awesome. D and B, Audrey could have also gave me A and C. Same reason. 2 inscribed angles drawn to the same arc are congruent. Perfect. All right, so now I have angle. Now you can tell me triangle ADE is similar to triangle CBE. Angle. Now, I'm not ready for the proof statement yet. I am not ready for the proof statement. After you show me two triangles are similar, the next thing you can tell me is true is that their corresponding sides are in proportion. How do I create that proportion? That comes from the proof statement. Because if I put AE right here on the top left, and I'm supposed to multiply it by EB, where the heck does EB have to go then? Bottom right, because when I set up a proportion, I solve it using cross multiplication. So they have to go diagonal of each other, and then CE and ED can go in the remaining two spots. Reason why that's true? We have a shorthand for it, but its corresponding sides in similar triangles are proportional. Now you can tell me the products are equal. AE, EB equal to CE times ED. And this would be product of the means equals product of the extremes. Done. Okay, so that was I just wanted to make sure I went over this because let's just say one of those four here are not chords. You wouldn't be able to use theorem number 2 I have up here. Questions on that? Proving them similar. Kyla, go ahead.
What would it look like if one of them wasn't a chord?
Let's say one of them, I extend this out here. I extend C and B out, but connect them as a tangent instead,
Oh.
and still ask for this. So we would have to do similar triangles. Yep. Any other questions on number 1? All right. Numbers 2 and 3, I loved a lot because there were so many different ways to do it. So many different ways to do 2 and 3. All right, to get to the final result. All right, here you go. Number 2. I'm sure the majority of you probably showed the triangles congruent and then said CPCTC. I'm sure that's what the majority of you did. There is a way, though, just to give you a heads up, and I don't know if anybody tried it or not. There is the way to get arc CB congruent to arc BD, and then say congruent arcs imply congruent chords. There is a way. All right, but I know a majority of you probably proved the triangles, which is good too. So let's talk. Tell me one thing you know is true about the diagram. Here we go. You guys are going to build this proof up, and I will do my best to go over all the different versions you could have had. So hopefully it represents yours. Maeve, go ahead. One thing that's true right now.
ACB and ABB are right.
Okay. Maeve says that angle ACB and ADB are right angles. I'm not going to write any of this down, by the way, just because, and I'll be honest with you, the people who did not even attempt it this weekend, I'm not going to feed you a free 3 points for homework. All right, so you can just copy down what I'm writing. Angle ACB and angle ADB are right angles. That's a circle theorem. Inscribed angles drawn to a semicircle are right angles. Okay? Inscribed angles drawn to a semicircle are right angles. That's what the theorem would be, that one. Then you could tell me the right angles are congruent. All right angles are congruent. Okay? There you go. There's 2 steps you may or may not have had in your proof. Let's keep going. What else is true in the diagram? 8. Ryan, what else is true?
I said arc AC is congruent to arc AD.
Yep, how'd you know that?
Definition of a midpoint.
Good, right from the givens, it said A is the midpoint of CD. So Ryan said, hey, arc AC is congruent to arc AD. Good job, Ryan. That is true. Some more true stuff you have in this diagram. 25. Sabrina, what do you got over there? Yep. So you said AB. Say those 2 again. I missed it. Okay, so you said the chords here, right?
Yeah.
So Sabrina's saying chord AC is congruent to chord AD. Congruent arcs imply congruent chords. Good job. I don't have enough yet to prove the triangle's congruent yet, though. All right, so I'm going to keep asking people what else you have. I said I don't have enough info. 7, here we go. St. John, what else do you have is true?
You have to. Wait, you can hear me, right?
Yeah, I can hear you now. Go ahead. Yeah, you froze on us. Go ahead.
Oh, sorry. I
Sorry.
said you have to prove them as right triangles.
Okay, so you said that they were right triangles. Where are you going? Can I ask where I'm just going to keep with you. Where are you going with that? Because I know where you're going, so I'm just going to stick with you.
Hypotenuse lake.
Okay, so before you said HL, we need to say AB, reflexive. Okay, yes, HL is a way to prove the triangle's congruent, but as you saw, St. John said, and a couple people from my first period class totally forgot this, if you're going to use HL, you have to tell me they're right triangles. Okay, so please make sure you have that in your proof if you prove them congruent by HL. And then, yeah, you could say CPCTC, CB congruent to DB. Everyone's all good. So HL, one method, HL. Another method of proving the triangle's congruent. Let me start from scratch. Everyone ready? Right angles, like Maeve said. Tell me they're congruent. Reflexive, AB. Ryan's statement, the arcs are congruent. Now take a look. Instead of going HL, you could have shown me angle ABC is congruent to angle ABD. Congruent arcs imply congruent. What type of angles did I just mark? What type of angles are those? Inscribed. So congruent arcs imply congruent inscribed angles. And now you have angle, angle, side instead of HL. Okay? Yes, Hannah.
So I did HL, and I did say that all right angles are congruent, but would you have to?
You don't have to, but I'm not going to mark off. It's a correct extra step, but you don't have to. Only if you're using HL. All right. Oh, here we go. Sophia, yeah.
I had side angle.
Oh, are you kidding? What?
Is that not a theorem?
Whoa. Side angle?
That's not a theorem, is it?
Why don't you just put ASS and just make, life a little funnier, I guess. Yeah, no shot. No shot at side angle. That's if you went.
HL was an option, but I didn't realize that.
If you see yourself writing SSA, that probably means you could have used HL. All right. Atticus, you had a question. And
I didn't mean to do that, sorry.
okay, it's fine. Kyla, go.
So I don't know if that was right or what I did was right, but when I said that angle ABC is congruent to angle ABD, in my reason statement, I said two inscribed angles drawn to the two equal arcs are congruent.
That's fine. That's basically in a nutshell. Yeah, that's fine. Perfect reason. Quincy.
When you're saying that arc CA and arc AD are congruent, do you have to write something first, or do you just go straight from definition?
No, you just say definition of midpoint. That's it. Emma, let's go. I love this.
So I just started by finding all the other sides. So I was gonna do proof triangles, and I thought that you could do subtraction on it. Is that a way to do it? Like the congruent arcs.
Okay, let's go. So where do you want to get to side?
No, I didn't prove a triangle. I just had.
So you ended up trying to get arc BC congruent to arc BD.
Yeah.
Okay, let's talk about that because your answer is yes. All right. So you knew that ADB was a semicircle, and you knew that ACB was a semicircle. All right. So what you needed to do was make sure you don't call it AB. Somebody in my first period tried to call it AB equals AB. Make sure you use the letters in between. So you could have said arc ADC congruent to arc ACB, and then said something beautiful like, hey, two semicircles are always congruent, something to that, that gets the point across. Then yes, you could have said ADB minus AD equals ACB minus AC, subtraction, substitution afterwards to get BC congruent to BD. Yeah, you're good.
Yeah, okay.
Yep.
Thank you.
And then congruent arcs imply congruent chords. You can do that. Yep, but I do need that the semicircles are equal.
Yeah, I saw
Okay,
that.
all right. Yep. Other questions? Whew, haven't even gotten to the third one yet. I love it. Yep, go.
When you wanted, how could you because with angle ADB, you could also say that it's an angle ADB and angle ACB. You could say that they're congruent because they both equal 180. Because it's the diameter.
Are you trying to say congruent arcs imply congruent inscribed angles?
Yeah, just that one.
So then you still got to tell me that the arcs are congruent.
How would you do you have to mention that they're 180, or would you just say because
I would just say arc ADC congruent to arc ACB, two semicircles are always congruent.
Okay.
So, yeah. Anything else on number 2? Number 3 is the same way. We're going to have a good discussion. All right, you ready? 3. Prove the triangle's congruent. Oh, and I should also mention at the end of this CPCTC. All right, we talked a lot about the triangles being congruent, but at the end, CPCTC if you did. Yes,
I
Hannah.
have a question for the third one.
All right, go ahead.
So we know this isn't a given that they're both 70. Would you have to say they're congruent?
No, you can just, if you did, fine. If not, I don't care. It's assumed that, given that they're both 70, we know they're congruent. All right, yeah. All right, here we go. So how did I prove those triangles congruent? All right, a lot of different ways. Let's talk. Give me something that you know is true. 0 for 2. There we go. Quincy, give me something that's true about this diagram.
BR equals YD because congruent arcs imply congruent chords.
Yep, perfect. There we go. BR congruent to DY, congruent arcs imply congruent chords. There's one thing that's true. So we got a side. Thanks to Quincy. Next up, 21. Zach, what else you got for me that's true?
I said BD is congruent to BD.
Oh, you sucker, huh? Going the reflexive way. All right, we got reflexive. You got me there. So we got two sides. We're getting there. Even if you didn't, just keep going. Whatever you know is true. Go ahead, Hannah. What else is true?
BRD and angle BRD and angle BYD are right angle.
Okay, so I have B angle R and angle Y are right angles. Inscribed angles drawn to a semicircle are congruent. Now, right now, based on what everyone I called on has given me, we got HL again, don't we? This is HL. Okay, so if you wanted to stop right here, tell me the right angles, and then say these two are right triangles, you got HL on your hands. Okay, so this is an example of HL. Other ways I could have done it. Here you go, ready. I'll do my best to go over every method. Instead of saying angle R and angle Y are right angles, you could just automatically say that they're congruent because they're two inscribed angles drawn to the same arc. So without it mentioning the right angles, you could just say they were congruent. Perfect. You could also say angle BDR is congruent to angle, where am I here? DBY. Congruent arcs imply congruent inscribed angles. Everyone see how both those angles are drawn to the 70-degree arc. Then you could say, I'll be right with you guys, then you could say BD reflexive, and now we have angle side. Right, now we have angle side, or without doing reflexive, I'll go back to what Quincy gave us, BR congruent to DY, and then we would have angle side again. So you got HL and two different versions of angle side. Yes, Sophia.
Do you need to write at any point that arc BR is congruent to YD or
No, you didn't. Nope. No, it's. I'm basically saying it's given because they both say they're 70.
Okay.
Okay. Yeah, I'm just saying that's a given that they're both congruent. Other versions? Anything else you want to run by me on number 3? What can you expect for the proof on the quiz? Okay, proving triangles congruent. CPCTC. Proving triangles similar. CSSTP. Means equal extremes. Anything's fair game. Okay, anything is fair game. You have 6 proofs that we have done so far. 6. I can't really find any more. Maybe you guys can Google circle proofs and find some on your own. So I am not going to give you any to practice with because there's not any decent ones out there I could find. So you have 6 to look over now. All right, 6. There's 1 on the quiz. Any other questions before we put this to rest and I start checking things? Anything else? Okay. You guys at home, submit it. You don't have a choice. You guys here, you can submit it on Classroom if that's easier, or if you have paper copy, I can just come around and take a look too. That's fine with me. Are you guys with the laptops going to submit it? Yeah. Is that easiest for everyone? Okay, so Emily, Zach, Sabrina, I'll just take you off the assignment. It makes it easy on everybody. Okay, so everyone should be set, no issues. And then we'll talk quiz 3 here. So let me see. Emily, I got a couple quizzes for you. Actually, just one. Up on the screen right now, you'll see what to expect on the quiz. I will be here after school today at 2:15 for anybody that wants to review, and tomorrow at 2:15 for anybody that wants to review. So I'll let you guys just soak that in, and I'll start talking about a couple things and do some examples with you. All right, let me start talking. 7 questions, 25 points. Equation of a circle. I'm sure, be prepared. It's not going to be in center radius form. It's again just a review with you. Center radius form: x minus h squared plus y minus k squared equals r squared. Be prepared for it to be in standard form, which makes you complete the square to get it into center radius form. Okay, so be prepared to complete the square to do that. Lengths of chords, that's segment times segment equals segment times segment. Secants and tangents is whole times external equals whole times external. But we are going to go over all different types in a second. Multi-part angle questions, that is from quiz 2. We did 2 of them. There's 2 of them on quiz 2. 1 proof, and then, I shouldn't be telling you this week 31 of the school year, but there will be factoring on there. You will be provided with the quadratic formula in case you feel the need to use it. So you do not need to memorize the quadratic formula. I will provide it for you if you feel the need to use it, but there will be factoring on there.
For number 5, the multi-part angle questions, those are going to be like, you show us a circle and then there's a bunch of different angles.
Parts A through F.
Yeah.
I'm talking central, inscribed, floater. What if the angle's on the outside? Angle formed by a tangent and a chord, all those, yep. The arcs, I'm sure, will be in some ratio that you got to find x for first and then plug it back in. Yep. Exactly. All right, where can you study from? First, just let me show you on Classroom. I put 4 worksheets on there for you. Under Unit 10, it says Review for Circle Quiz 3. You got practice for chords, practice for secants and tangents, circle equation practice, and I put the 46, 42, whatever it was, multi-part circle questions back up there. All right, again, the only thing I don't have for you is proofs. And that's just something you have to deal with and review your 6 that we've already done. All right, so that's up on Classroom for you if you choose to partake in any of that. You also have your packet, the back of your packet, which I'm going to go over a couple of these right now. Can you guys go to number 10 in the back of your packet for review? Number 10, please. I do want to just touch upon each topic briefly. I'm only going to do 10. 11 is very similar to it, so I'm just going to do 10. All right, so I got a diameter and a chord perpendicular to each other. Before I even talk about 16 and 16, anybody see a theorem that's being used here? Let's start there. Even before I start labeling my diagram, there is a theorem being applied already. Quincy, what is it?
Diameter perpendicular to a chord bisected.
Yes, the chord is getting bisected. A diameter or a radius perpendicular to a chord bisects the chord. So before I even put any measurements down, I know line segment AE is congruent to line segment EB based off that theorem. All All right, now I can throw some numbers on. Chord AB is 16. Oh, well, good thing I know that theorem because now I know AE is 8 and EB is 8. And CE is 16, however you want to show that. How long is ED? All right, what do I need here? What do I need to find the length of ED? And I am going to call on people here because we need to review here. And some of you need to take this pretty darn seriously. First grade of the fourth quarter. First grade of the fourth quarter. 5. Hayden, any idea what I can set up here to find X?
We can do 8 times 8 equals 16 times x.
Good job. Ready? Set when two chords intersect, the product of their segments, 8 times 8, is equal to the product of the other two segments of the other chord, 16 and x. That is the theorem Hayden is applying. 64 equals 16x, x equals 4. And when I say be ready to factor, it's these type of problems be ready to factor on. Okay, segment times segment equals segment times segment. You might have to factor at the end. Here we didn't though. All right, I'm going to move on because 11 is the same type, just different numbers and different segments. How about 13 now? 13 with me? This is a secant and a tangent now. Secant and a tangent. The whole secant is 20 units. Its external segment is 5, so 5 on the external. Find the length of the tangent. Another theorem. How do I find lengths of tangents and secants? Because it's not segment times segment. That's only for chords intersecting. All right, what are we setting up here now? 16, Kyla, what are we setting up here?
Is it 15 times or plus 5 squared?
Ready? Whole times external.
Oh, yeah.
Right, yep. That's why we're reviewing it. Whole times external. This is for secants and tangents only. Secants and tangent lengths. I do whole times external equals whole times external. All right, so go ahead, Kayla. Give me a whole secant length.
20 times 5.
Yep.
Equals x squared.
Here you go. Tangent, whole, and external are the same values. So x and x. Yep. And now we're on our way. 100 equals x squared. X equals 10. Now you guys will see in diagram number 13, that was a secant and a tangent. Does it matter when I go to 14 now that they're two secants? Nope, same theorem. Any tangent secant combination, same theorem. So PR 24, PT QR 16, PT 16. And what am I finding here? PS. It does not matter. Now it's two secants, still the same theorem. So I'm going to ask somebody to set this one up. Top of the page. Vinny, what do you got? Set it up for me. What should I solve here?
24 times 8
Good.
equals 16 times x.
Good. If you're wondering where Vinny got the 8 from, that's external. 16 is internal. So we did 24 minus 16 and got 8. Perfect. So we end up with 2, carry the 3, 192 equals 16x. X equals 12. PS, yep. And please just make sure, because I just did the answer key last period to this quiz, make sure you read the question and make sure you answer what is being asked. Okay, because you never know, you might need to plug it back in. I might not be looking for PS. I might be looking for something else where you have to plug X back in. Any questions there? And one more I wanted to go over with you, which deals with circle equations, number 25. This one's a tough one. So you got an equation of a circle. I give you the center is 2, -4. So just for visual purposes, I'll graph it for you. So there's the center. You know what? I'm not even going to read the rest of the problem. You should be able to eliminate 2 out of those 4 choices right now just by knowing the center. Go from a 25% chance to a 50% chance right now. Which 2 up here would I be able to eliminate just knowing the center is 2, -4? And again, remember how it works. X minus h all squared plus y minus k all squared equals r squared. All right, here we go. Which 2 should I be able to eliminate right now just knowing the center and nothing else? St. John, which 2 up here can I eliminate?
I'm still thinking.
Okay, that's fine. Let me know when you're ready. 2, -4 is the center, so 2 of those answers don't make sense.
Get rid of the second and the fourth.
Second and the fourth.
No, actually, the first and the third.
First and third now. Why do you say that? Right now, don't. And I'm just talking center. I'm not talking radius at all. What's the x coordinate of the center?
2, -4.
No, just the x coordinate. What's the x coordinate?
2.
2. So when I plug that in, I get x minus 2 squared, not x plus 2, right?
So you would get rid of the third and the fourth.
There you go. Everyone else agree. I get rid of the third and the fourth. Even if I did the y coordinate, it would be y minus a -4, which becomes plus 4 squared. All right, so I narrowed my chances down now to 50%. So is r squared going to be 4 or is it going to be 16? Well, let's keep reading now. And is tangent, what's tangent mean? It hits the circle one spot only at x equals -2. All right, this is a tough one because, hey, we have to remind ourselves, what type of line is that? X equals any number? Don't tell me straight, they're all straight. Vertical. X equals any number is vertical, right? You only had one more shot, babe. So I have, here you go. Here's x equals -2. So it's tangent, and I'm going to do my best here, to that line. So just to give you a visual here. It's pretty darn good. There it is. Tangent hits in exactly one spot. That spot's called the point of tangency. And what do I always know about the radius and the point of tangency? Or the radius and the tangent then? They're going to be perpendicular. So if the tangent is vertical, what should be the radius then? Definitely what? Horizontal. If I'm going to form a right angle. How long is the radius? 4 units, but anybody want to tell? That's not what I plug in the equation. What do I plug in the equation? 4 squared. So that's why it's going to be 16 here. Okay. Yes.
Will we get graph paper if we wanted to graph?
If there's a graphing type question that you would need it for, I would give it to you. Yeah.
So like
I don't think there would. Yes, a problem like this, yeah, definitely. Anything with coordinates, yes. All right. So you know there's 4 different worksheets on Classroom. Also in your packet, I'm just going to give you those numbers right up on the screen right now. Those are ones that would pertain to quiz 3. Some of them you may have done already from quiz 2 because we did the multi-part circle question. So I'm giving you everything that pertains to quiz 3 that's in the back of your packet. And I realize some of you may have done some of these problems already getting ready for quiz 2. All right, but those are the ones that pertain to quiz 3 up on your screen. And then from here, you guys can go from here. All right, whatever you need to work on right now. Okay, through the end of the period. You guys tomorrow, you'll log on. I'll probably keep you for half the class and then I'm good. All right. There is no Ed Puzzle video. All right, I am done with Ed Puzzle videos for the year. Reason being, now that there's no final exams,
We have like 3 months.
we have an extra 2 weeks now. So why am I gonna, try to get ahead? We'll just do every lesson together in class instead of on Ed Puzzle.
You have like so many extra.
Yes. We'll be fine in here though. We'll get through all 12 units and then I will start probably some Algebra 2 curriculum. Just so when you guys see it in September, it'll be the second time you see it.
Will we have tests on the Algebra 2?
Probably little quizzes, yeah.
Oh.
Yeah.
Are finals,
No.
are finals canceled or is it just regions?
Finals too. Like I can't give a final as much as I want to, and you guys should be taking a final as honors kids. I can't give one.
Is the math region like, can you opt into it or is it just canceled completely? 'Cause I
Not
knew-
geometry, no.
Okay, because I knew.
Only
I
algebra.
was in Algebra 1 then.
Yep, you can't. They're not making one for geometry this year. They're not making one for geometry.
There's a list. If you look on the website.
There's about 4 of them you can opt into.
Okay, well they emailed you. They emailed me.